he can just see the file.
Okay, got it. We're recording.
Okay, good. Well, then let's just get going. So, all right. So what we wanted to do is have this video conference so that we could do a live streaming video demonstration of the RS1 right here. Okay. So we've done quite a bit of work on this product. I guess it's been a year and a half or maybe 2 years, probably 2 years. On and off, right? Hasn't been 100% dedicated to resolving everything because we've got other things to do, but it's now in a state where we can sell it, and we've already run some samples with it and got some performance criteria out of it, and we're really pleased with the selection of the components that we used for the design of the product. And the big thing is that, you know, as we go through this and as you think about this RS1, you need to always compare it to whatever else is in the marketplace. And that's what we do when we do a design review, or we make a plan on how we're going to build a product. We never want to be me too. We don't want to be like anybody else. We always think there's a better way to do things no matter what we're doing. And so it may take us some time, but we always come up with a better solution. And so this is an example of that. If you're familiar, as you become familiar with the market, the competitors in the market space that we're going to be competing in, you'll see there are some big major differences between how we do things and how they do things. The chemistry, no, the chemistry is all the same. The method of making a measurement, the absorbance method, always the same. But our photometer and our approach to doing this is has a little more precision built into it. So as a simple introduction before Richard gets started on defining everything to you, this is just a product that reacts takes a sample and reacts with a reagent that it mixes to form a color. And all the applications, not just silica, but all the other anion, cation applications that we do or can do are color forming kind of applications. The benefit of what we are doing is that we do it in a very precise way so that our standard error of estimate is super low, and that's a big benefit to the end user. So with that, I'll let Richard go through and talk about his software, talk about how the unit operates. Well, we're running samples right now, and we'll zoom in on the product because you can't see it very closely, but we have a separate camera that can zoom in on the software so you'll be able to see it. And then feel free to interrupt with any kind of question or write a question down, and then ask it when there's a little break, but you can always ask it while we're performing, you know, our tasks here. So, Richard, everybody knows Richard. This is Richard.
Hey, I'm Richard. I'm a mechanical engineer at Custom Sensors. So have you guys seen anything about this yet? Do you know any of the mechanical features? You do?
I've given them a manual and I've talked to them about it, and they've seen literature. That's it.
Okay.
So there's still a lot to learn. But
I will briefly go through kind of the high level, which I'm guessing you guys have seen this image before.
Yep.
Yeah. So again, essentially, you know, the theory behind the device was that, you know, we were going to make essentially the highest accuracy, least expensive, and smallest device that, you know, we could possibly make. So, you know, mechanically speaking, the device is pretty simple on the surface. It's, you know, largely just two stepper motors. One stepper motor actually controls a rotary valve that will select from different sample ports, whether it's actually a process sample itself or a reagent. And then there's another stepper motor that actually controls a piston pump that will actually meter various volumes of either sample or the reagents. Basically, you know, the measurement process is relatively simple. We will pull in a certain volume of sample. We will mix it with up to 3 different reagents. And once the reagents have all been mixed and settled, we will actually move that over to the left here to this measurement cell, where we'll actually make, you know, the photometric measurement on it. So, you know, in terms of mechanics, like Mike said, if you look around to other people on the market, you know, this device is pretty far advanced in comparison to everyone else, because usually there's like an array of, you know, solenoid valves and peristaltic pumps, and really this design is just super simplified, you know, and integrated to make everything really simple, really robust, and really easy to actually, you know, repair if anything does happen to it. So that's really the theory. So let's see here.
So I'm going to interject just a second here.
Sure.
This is something that, you know, I can go back to my old sales days. In my limited understanding of this product from Mukesh, because, you know, he's the subject matter expert here on our side. So the piston pump versus the competition. So it's my understanding that the peristaltic pump that are on the other products, they're maintenance intensive, or they have a high failure rate and they need to replace the tubes, this, that, and the other. So how can if I'm going to articulate this value proposition to our customers, this design versus the competition, I want to make sure I can articulate that. I think I got it, but I want to make sure I do.
Yeah, so and we could probably, really what we need to do is just probably provide you just a bullet point list of why we are better than the others, and that's easy to do. So we'll do that, but I mean, really, again, the value proposition really would be lower maintenance. Hopefully, you know, after we get rolling and, you know, can compete with these higher volumes with Hawk and everyone else, it's gonna be less expensive once we start manufacturing, you know, hundreds of these at once rather than, you know, 5s and 10s. We're gonna have a lower price than they are.
You know, I'll interject right there. I don't think that's necessary. You know, from what I've seen.
Well, that's up to you. Yeah, that's up to you. But our costs will be lower than theirs. Yeah.
Our margins will be higher.
You know, I'm not one to, you know, just sell on price all the time. I think that's why I asked for the value proposition. I think once we have that identified, then I really don't care if I'm going up against these established brands. So I think we can beat them. And I think the traction that we've already experienced is that is not the issue. So the way I look at it is I try to go ahead and talk to individuals that are decision makers that are involved with both capital expenditure and operational expenditure. So in other words, they own the P&L. And so if I can show them on the post sale that they're going to be saving costs, they really don't care. I mean, honestly, this thing can come in. This thing can come in twice the price as heck, and I don't care. I mean, I can sell it. I can sell it because they're looking at their entire P&L. So I'm not going just to the maintenance guy. And, you know, he's got a budget that he gets every month, and he's got to stay within that budget. I mean, that's not the way to sell these boxes or these products. So again, you know, the price thing, I wouldn't even. I think you got to, you know, if this thing does everything that I think it can do, then the price should remain the same or even be bumped up.
Yeah. All right, great, yeah.
Well, I'll make a list of bullets for you, but basically the piston pump has a much higher degree of precision in terms of its volume control than a peristaltic pump. And if you look, the first thing that I did is I looked at the specs on all the other competitors, and their specs are within 5 or 10% accuracy, right? This will be 1 or less percent. We just did, how many did you do? You got 500?
Yeah, earlier today we were scaled to 500, and again, we'll give you some nice data on this, but we're about plus or minus 2 ppb over 500. A 500 ppb range. So, you know, less about a 0.5%, you know, accuracy. So pretty good.
So that's really good. So, and then when you start to see the software, I think the software is really what's going to sell it. That's where all the pizzazz is. So let's go continue. And then
so okay. Yeah, okay. I kind of lost where I was at. Okay. Yeah, so we can just dive right in then. I guess, do you want to hop on the phone?
Yeah.
We'll kind of just navigate you guys through the features, you know, of the you know, the software here, and kind of show you some detailed views of everything that's happening.
Okay.
So you see all right?
A little better.
Yeah, just got clear.
Yep.
Should we turn this off or not?
Let's
It's
see.
gonna be.
Yeah, no,
don't
turn the
know.
light back on. Yeah.
There you go.
Okay. They'll see it fine.
Okay, essentially this is kind of this is the actual home screen of the analyzer. You'll get you have a bar chart of actually your last 10 measurements here. This is really kind of the home base for, diagnostic information like reagent levels. If there are any alarms or issues with the instrument, you'll see that on display right here. And it will also give you, the option to either do continuous measurements, a single measurement in the event you want to do a grab sample. So if you'd like to go, up to a pipeline, fill a cup up with whatever sample you need to measure, you can just do that, pop it underneath the unit, and then hit the single measurement and run the unit. And there's also, a cleaning feature that essentially just mixes water and acid through the sample system, and will clean any scale or anything like that out of there.
Start at the top and just sort of work down. That way they can kind of get a orientation. So the first thing is read the number, I guess. Start with that number, 348.
Mm-hmm.
So the first thing would be that if you look at the very top, I need a pointer. Oh, I got my pen here. Hold
Yeah,
on.
I mean, so
Yeah.
is that clear? Yeah, it's
Yeah.
essentially your current measurement output.
It tells you the current measurement output, the engineering units. And then over here, which we don't have, I guess we haven't put any numbers up there yet. It gives us some statistics on the averaging and standard deviation among all the different repetitive cycles.
You guys having a hard time seeing?
Can you see it?
Yeah.
Can you see
Is
it?
that a touch screen?
Yeah.
Yeah, it is touchscreen. Yeah, so I'll kind of navigate to some different screens here. So essentially, we have password protection. If you want to, if a user wants to go and calibrate or really modify anything or do anything manually with the instrument, you're going to obviously have a password to enter. So this is essentially the calibration screen. It's extremely simple. The calibration process, all it really involves is having a calibration standard connected to the unit, simply typing in the value you want to calibrate to, 500 ppb, and hitting go. So you just hit continue. It will automatically step through all the processes needed to calibrate, zero and span points for the instrument. Super simple, couldn't be easier to do. So
Maybe if you kind of orient your thing a little bit. So it's if you look at this shot, it's kind of off. You kind of square up on it. Come up.
Yeah, it's
There you go.
reflections kind of.
Oh, I see. Reflections, yeah. Okay.
in a deeper settings screen here, you're allowed manual control. So if there was an event that we need to do some diagnostics or actually just test something a little abnormal, you can actually manually choose which valve you like, with which reagent, which valve you'd like to choose. You can manually manipulate the pump position itself, and just lower level features such as just priming the pump. So it's an automated feature that will actually pull in if you're going to replace the reagents. It will automatically, prime all the different reagent bottles for you with just, a touch of one button.
Okay.
So that's a nice feature. In that, we actually monitor the reagent levels. So every time you make a measurement or pull a, reagent, we automatically decrement the volume that's used. So after, a series of measurements, the software will warn you when the reagents are getting low. It will set off an alarm, letting you know via, it will do it via the display, Modbus, and actually an alarm relay on the back of the unit. So that'll let you know when it's time to actually replace your reagents.
Quick question, how many relays you got?
We have one now. We have more available on the board. So we basically generally have one general alarm relay. We do have a more available in hardware that we're just not using in software yet. So if that's something you'd like to see expanded, we can do it.
customer wants two additional relays for controlling 2 points.
So if we got a customer now that wants 2 additional relays, is that possible?
Yes, it is.
Okay, apart from the alarm.
Correct. Yeah, actually, I can explain that more, but we actually have 16 available. So
Okay.
we're not using like I said, the hardware is there. It's not in software firmware yet, but not a big deal. So what would you want to use the relays for?
For controlling 2 points, like lower alarm or higher.
Just additional alarms.
Yeah, here, like I said, we've got a, yeah, I'm gonna switch it. Dr. College just walked in the room.
Okay.
So, the reason why we're asking these detailed questions, and I apologize for cutting you off, is that
No problem.
we've got a customer in hand that's probably gonna need 3 of these here, literally PO cut in the next couple weeks.
Okay.
So see, these are, we already know where their requirements, so we're gonna throw those out there as we go along. So I apologize for cutting you off, but
No,
No problem.
fine.
we've got another meeting with them this afternoon to finalize some stuff, so. Okay, keep going, sorry.
Yeah, please, share, email Mike or myself, please share any information you guys have so we can, get on it, whatever other requirements you guys may have. Let us know as soon as possible so we can start working on that.
Okay, great.
Yeah, anyway, so this is just kind of the general setting screen here, so you can manipulate. When it's time to replace your reagents, you can reset them back to 100% if you'd like. You can manipulate the measurement interval. You can set a cleaning cycle interval. You can set an automatic calibration interval. And you can actually change the Modbus address as well for Modbus RTU from this screen. So that brings up, another feature. It is intended, you can leave a calibration standard essentially permanently connected to the unit. So, if for long-term, unattended, measurements, you can set up an interval to actually automatically recalibrate the unit every 100 measurements, every, 1,000 measurements, whatever you want to do. So that's a variable that we can set in here for automatic calibration. So it's another pretty nice feature. Not really much else to show in here. This is essentially just a calibration data screen. So what this will do, this data is actually generated automatically during the automatic calibration. But if a user finds it necessary to quote unquote tweak the calibration points during process, again, it's just a simple feature of just selecting what point needs to be modified and just keying in whatever value you need it to be.
Lokesh, you might notice you have that PX2, and if you notice all the icons on the bottom here, exactly like the PX2. All the products that we make have these same kind of software features. So once you get to understand one of them, you'll easily adopt and understand the rest of the product line too.
Again, this is just a lower feature to it. If the user can reset the pin to anything they'd like. So again, you can just key in a new pin, hit enter, and save your pin. About simply just displays all the software and firmware versions and gives you a serial number for the unit as well as our information. And that's really, I hate to say it or I love to say it, that's really all there is to it. It's not a very complicated system to use. Like I said, you can automate calibrations, you can automate cleaning, you can pretty much the entire system, is automated. So in terms of, I guess, hardware, I can kind of show you what's happening in here. So essentially, really the hardware itself, this is our main kind of control circuit board that, controls the pumps and, has any relay outputs, anything that you need on it, like I said. So this is actually, a lot of these connectors aren't populated because we're not using them, right now for this current application. But we have 4 4 to 20 outputs, 4 4 to 20 inputs. We have RTDs. We have DC motor drivers, and we have 16 solenoid/relays. And we also have the optical or Hall sensor inputs as well. So there's a lot of power within this circuit board here. We also have, SD card logging. So if the communication goes down to the user's DCS, we also log to an SD card. I think I mentioned too earlier, Modbus outputs as well, RS45 are right here.
You should know where all the relays are gonna be, yeah, right there.
So really there you can just kind of see the mechanics in action. It should be moving some fluids around here in a second, but essentially, really another nice feature is, again, just ease of maintenance. Really the only things that, are really going to break on this, if ever, are going to be the LED light source. And I'm going to just go ahead and I'll show you guys how to unplug it here. If one dies, it's a matter of just getting a new one, screwing it in, and reconnecting the electrical connector.
So the LED, what's your estimated failure time on the LED light source?
I'd say 5 to 10 years. So
They last a long time.
they last a very long time.
And the estimated cost on replacement?
22 cents.
Yeah, no. So we'll probably ship it with an optical filter as well. I'd say, let's say a couple hundred.
All right. That's not a biggie.
Yeah.
So you can see the pump going up and down.
Yep.
And then it will pull sample, and then you'll see this chamber over here fill up. That's a reagent reaction chamber.
Okay.
This right here, we're not using it right now because we don't have any, obviously, pressure motivating the liquid through the system. But this is actually our fast loop for the side stream connections. So we have an alarm on that as well. So if the customer's fluid is not being pumped through the system, we actually monitor that here, which is a little level sensor. So if this level sensor senses that there's no liquid in this volume here, we know that we cannot make an accurate measurement, and we do set off an alarm for that as well. So one other feature that's maybe, it's been interesting to some others is really that we're about half, we take up about half the wall space of the nearest, the closest competitor. So if space is at a premium, we win in, every scenario there because we're much smaller, take up a much smaller physical volume.
2 feet, and width is about another 8.5 inches. 8.5 by 24 inches by 8.5 wide. That's just this section here. Then you have the area down here where the carboys are, right, where you store your reagents. We don't store them like this. We just did this for the demonstration. But there are standard carboys, black bottles that you can get. We should have some around here someplace, and they fit in this bottom chamber. So there's mounting brackets on the back of the box that you can mount to a panel or whatever. But I think the small width is really good because usually every power plant I've been to, they have rows and rows of these things, and so you can get a lot more of them in a smaller space. Well, here's a reagent bottle.
So, right, yeah, this is a 2 liter. So this would be what we do. Oh, can you see that?
Yeah.
That'd be the standard bottle that comes with the system.
You can get those locally,
Or whatever you guys want to do there.
And then what we also do is that maybe you can zoom in on this.
Put myself on hold.
Oh, you did?
There you go. Hold on.
Question.
Sure.
What's the environment, the temperature environment that this is
The machine
for
and
the
reagents.
for the machine and the reagents?
We are roughly, oh God, I just looked it up.
50C?
50 C max for sure. Min, I can't remember off the top of my head. We're above 0 for sure.
Yeah,
You
we're in
got
time.
to be concerned about, yeah, right, I know in Thailand you don't have 0, but
Yeah.
those cold weathers, you got to worry about the freezing of the reagents and stuff, so. They typically have lower temperature freezing points, but
I can't remember the last time it froze here, so we're good, but
Yeah.
we have, we have the requirement. This is
Yeah.
to, again, the first customer we have is a raw water provider. And they own the entire water grid for eastern part of Thailand. So this could turn into, they want to do 3 locations first. And they're providing water to both the industrial as well as the, the consumer market. So tap water as well as into the refineries and everything. So just to give you a heads up on what the background is they've got some, this is the one with the manganese requirement, first and foremost. Then
water
they've got
hardness.
their raw water that they provide to the refineries. They want to provide an extra service, and that would be providing silica readings before it gets to the factory, because they'll do it at the refineries, but they want to give the customers a heads up, that and the water hardness, which is a separate issue.
Yeah.
But anyway, so they're going to be putting these over by the pump stations, and that's why, but that's outdoors and that's hot, and so that's.
Well, typically what happens is that most installations that are outside get put on some kind of a platform, concrete pad with a rain shield or a sun shield, something like that.
Yeah.
Or you could even make a walk-in shelter if you wanted to, right? And have them doing a walk-in shelter. That's temperature.
What's the protection class of the cabinet?
Name of 4X.
Just, hose down.
They've already got the concrete slab, and most places have a shed type, they're not
Yeah.
gonna leave it out in the open, and it's gated around, so it's at a pump station.
Yeah.
So, but there's no AC obviously in that, that building or the
Yeah.
shed, so it could potentially get hot.
Yeah.
So we need to find another way to.
Well, and if it gets too hot, they're going to have to put a fan in there or something like that to circulate.
And we've done this number of times before. I mean, there's a number of companies out in the market that just sell thermoelectric coolers for these types of enclosures. So, if we get some specifications from you that say, hey, it's going to be 250 degrees outside, we say, hey, okay, we're going to put a TE cooler on this. We're going to charge you an extra $400. It's not going to kill us. So.
Okay, no. Again, I'm just. These are specifics to this one application, and again, it's a hot one, so I apologize for veering off course a little bit. But this is one that, it's a no bid situation. It's either us or nobody. It's a very, very good opportunity, and as I said, this company owns the entire grid. So we're looking at, we're not looking at a 3, 5, 10. We're talking, big numbers. All their pump locations, right? So they've already shared with us, and they want to start with 3. They've got a budget that's gonna be, he's got to use this money quick. So I'm like, great, I'll take it. But anyway, so I apologize for getting off topic a little bit, but that answers that question. So 50C, and we may need to, maybe if you can come up with the costing of what it would cost for the cooling device. I mean, I have a feeling we're going to provide him with the final numbers most likely at the tail end of next week, and then he's going to make a decision on the spot. I personally already know what his budget is or how much money he's got to spend, so I think we're well within that. So the discounts are not the issue. It's just making sure. I don't want to stumble on this one, because if we do, there's just too much downstream that really could materialize. So
Right.
It might be a good idea. This is my idea for if you get this order and then we get the order and we build the products, and before we ship it, we maybe get Lokesh to come and visit us, if that's a possibility. And then we can go through the checkout with him. He can have physical hands-on. He can become super familiar. And if it's not Lokesh, it should be someone, so that they can have a custody transfer of the product. Now it's yours, and you know exactly how to operate it. And if something happens, you know what to do with it. So, we went over this whole thing pretty quickly this morning for you. And there's still a lot that we could talk about, and we could spend a lot of time on each one of those screenshots and tell you why we did certain things. Richard did a pretty good job of explaining a number of those things, but you can't absorb everything. And like I said, we've been developing and designing and reiterating on this for a couple of years now. And so there's a lot that we could discuss. And if it's that important, I would suggest maybe, sending somebody to visit us. If you don't want to do that, we'll just have more of these video conferences, because eventually what you're going to have to do is that, you're going to get this thing and you're going to be able to make it do whatever you want, right? We showed you how you can change the volumes, how you can add different reagents, how you can do all these different setups. You can put all the different kind of chemistries in there. We can help you select those chemistries if you want us to, but you're eventually going to have to do your own factory acceptance testing at your shop. That means you're going to have the reagents hooked up. You're going to have the customers come in. They're going to run these samples. You're going to see the reproducibility. So we can't do all of that. I mean, we can build a product for you. We can support you any way we can, but the rubber hits the road on your side. So you're gonna have to do the customer support there. We'll support you as best we can, and I think that we'll do that for you. We've made a commitment to your company, so you need to think about that.
Okay, well, for the meantime, I would say I need location over here to get these things closed first and foremost.
That's fine.
I'm coming on, my background is not necessarily in this field, so I'm learning as I go. The only thing I bring to the table is I can sell things, right? So
that's a good feature to have.
That's really important.
That's a good attribute.
Yeah, I'm selling ice to Eskimos. I can do it all, right? So, but at the end of the day, I need the technical support. So, maybe we do a couple more of these video conference calls, and as the need arises, then we can take that, to the next level, whether or not it goes over. But the other thing is, so the takeaway from this conference call. So if you could still, circle the wagon and provide me with those bullet points on the value proposition. And then also the dollar for the, what the costing would be for the cooling, because my gut tells me now we're probably going to need it. Because you're right. You're probably joking about that 250-degree temperature thing, but in the sun, and then some of those little huts, I mean, it gets steaming hot, and I'm sure they've got a lot of other, they got other expensive gear in that hut. So but again, it's a pump station, so I don't know. No AC for sure.
Sure, and like I said, it's not a humongous cost, so I don't think it should really deter anything. So yeah, we'll get it together for you.
Okay. Anything else?
Yeah, for maybe we can ask them to share the reagent details for.
Oh yeah, that's right. They wanted to know that. For manganese, the reagent details. Lukesh wanted to know, how that process would go down, or how
range can get listed for the.
We've done the water hardness, as the calcium and manganese and magnesium, right?
Magnesium,
Yeah.
Calcium, magnesium. So yeah,
So
essentially.
we've done water hardness chemistry before, and it's calgamite is a reagent.
But they want manganese, not magnesium.
Oh,
Manganese, we'll have to get back to you. I'm not sure if that's something we have. I don't have it in my book of applications right off the bat, but we can look into it.
And then, I'm going to need to know what the concentration is.
Yeah, okay, we provide that because it's on the brochure. It says manganese.
Oh, yeah.
Okay, well then if it's on the brochure, then we've looked at it. I just don't know what it is off the top of my head. And
That's the primary application is the manganese right
Okay.
now.
Oh, very good.
if we put it on there, we researched it.
Yeah, we can absolutely do it. We just haven't done it yet.
Yeah. We'll get to you on that. We'll tell you about that.
Okay, fair enough.
What else?
How the discussion was going around, all the discussion going around Mike now for all the things.
Good.
That's nice.
In your absence, Dr. Kala, in your absence, we started to videotape this presentation. So we have it videotaped and we'll send it to you when we conclude it. So you can see the beginning of it.
Okay, what is happening actually, there are some of the applications which are moving at present, which I was telling you last time, the manganese and silica on a prime.
And copper.
And copper, yes, but mainly which I can see the potential on manganese at present and silicas.
Okay.
So what I'm looking forward that to get a demo here as soon as possible.
Okay.
And I was telling, so some demo we will install to the customers which are looking like very strange customers, and they are feeling that they cannot believe that the other models can work on the silica application. So we will install parallelly to the hack and make a T in between. So we take our sample parallelly to hack and see the performance, how it is working. So that will give them the confidence that we are at par or better than hack.
And most customers are asking us to do that. That's the same thing. So a side by side.
The strategy behind it. So once we install a couple of applications, then we will take these instruments to India, and then we will install the companies like IOC, or that is our prime at present.
Good.
So that is the strategy, and 1 or 2 units maybe we will require on a quick delivery basis. So I don't know how the production you will be doing better. So maybe around
We can crank it up. We just, what we really are gonna need, I mean, you know what I'm gonna say, I'm gonna need a forecast here. As soon as you can possibly put something together, a forecast with your probability of getting orders for certain kinds of applications per month. You know, or if you want to go per quarter, whatever, just, I know you're just getting started too, so it's not that easy, but once we get rolling, you need to at least communicate that with us, so we make sure that we have all the raw materials to build this kind of product for you and get the product delivered to you.
Okay, and you may be housing this, all the housings you may be outsourcing.
No,
Yeah,
what?
we machine all the actual mechanical features inside, but this is just outsourced.
Yeah.
Yeah, so the enclosure itself is, we just purchase it.
Bottom line is that for the outsourcing, if they can deliver to you in 3 weeks, those housings, so I think in 4 to 5 weeks you can deliver the unit.
You're asking lead times? I'm sorry.
Yeah, I think so. I think it's lead time, right? Was the question? Well, I think remember I talked to you about, you know, we were gonna provide just hardware for you, and then you were to do the assembly. I think that's a bad idea at the beginning. I think what we're gonna do is just gonna supply the whole product to you, and that way all you have to do is
No, yeah,
connect.
I want to take that risk. For a couple of units, we will take the complete unit from your side.
Yeah.
And when it is stabilized and the clients have a faith that units are perfectly all right, then slowly by next year, we will try to do those housing and these things in Bangkok.
Okay, that's fine.
So that can be helpful for for the major plants or some big countries. But actually, strategy is very clear. We will take everything 100% from your side.
Yeah.
Only we are talking about the preconditioning, some sample preconditioning that we will do in Bangkok.
Okay.
That we are capable here, and we know that how to do the preconditioning.
For example,
Yeah, that we can do easily here.
Yeah.
And then we will club with your unit and show to the customer that how it works. And after he does some sort of a testing here in our lab, we can install at his site easily. So
Excellent.
the Raymond is putting a lot of efforts at present with a couple of major companies. So as far as Thailand is concerned, and we are looking forward some units to be through very soon. And in India market, our tendering is going around, and the team is doing a good job at present and getting approval. And IOCL, especially in India, those units are approved now and will be through very soon. So that's a strategy. But one demo unit will either in Thailand or India, these 2 countries mainly. A lot of video conferences they have to do it.
Okay.
But the time gap is there. I understand it is late 9 o'clock, 9 p.m. to you, and we still manage some timing which is more convenient to you. And my people, they can also adjust on the timings, and then we do it more and more conferences on that.
Oh, yeah, no,
Excellent. No,
we'll
we're
work
fine.
that out. That's
Yeah.
not a problem. And maybe there'll be times in advance in the future where we could just do a video and record it and send it, and then we can do something like that. And
Yeah.
if you have a specific question that needs to be demonstrated by us, we can video that and send you the answer. That way, you keep a library of these things as we keep sending them, and you'll have a full list of all the information in a reference library that you can go to if the problem comes up again. You can say, oh yeah, we had, and organize your library so you know what each one of the videos is about. You should be fine.
That is perfectly good idea, and then we can take over from there. And
Yeah.
I think we will take a move to this, and next video conference we can do around in 15-20 days, and for some further discussions. And there are some small points I will drop you an email. I just noted it down. I will drop you an email, and then we can clarify those points. And otherwise, everything is great. And let us hope that.
Okay.
Yeah, excellent.
Great. Well, I'm glad to see Ray's on board. That's good. Good news. I met him at that water quality show and the last time I was there. So I'm glad that he's now entrenched in the Braston organization. So good luck to you, Ray.
No, we will do it together. And
Yeah.
as I was telling them also that, when I met you first time, on my request, you developed this silica unit.
That's right. Yeah. Yeah. I told him that. He said, well, we're looking for that. I said, well, we'll make one for you. And so here we are 2 years later. Right. Yeah. So you have to sell it now.
Hopefully by the next conference call, I get at least 3 POs in hand. I think that's what we're trying to. So if we're looking at 15, 20 days out, the next conversation is going to be, okay, how the heck do we get a couple of these boxes over here quickly? Because, it's moving. As I said, your product is hitting. I mean, with all the parameters that you got listed on your brochure, the ones that have been popping up, obviously, are silica, manganese is a real specific one. I don't think we're going to see that one again, but it is one that has popped up the eastern water corridor for some reason. There's a high concentration of manganese in their water supply. So, and they've been all over the map, and it's not something that the government busts them on, but it's something that their customers, they're selling the raw water to, other entities. And they've come up with some issues. So they can't treat the water, but they have to inform the next party over that, okay, the levels are fluctuating. Right. They think the causal is there's some sediment in some of the big pipes that they got on their water grid. But again, they're not looking to fix it. They're looking to report it. So I think that one's. But again, that's before that subsides. I have a feeling that's probably going to end up to be close to 30 units, starting with 3. So if 3 works, they're going to be 30. But then I think manganese is probably going to go by the wayside. I don't know if I'm going to find another one of those. But the other application that seems to be popping up sporadically is copper. Heck they've got an older product which they've discontinued. And we're finding out that they're no longer manufacturing any of the parts for it. Oh. And so some of these wastewater treatment plants and some of these other the wastewater, right? IHE? Yeah. Wastewater. That's popping up. But I think if we were to categorize what we're going to need from you, is first is going to be silica, obviously, with the power plants and with the turbines and everything, and the boilers. Number 2 would be the raw water application that we have in hand, and then a third would be the copper. So if you're asking for which parameters you probably need to focus on and help us out, those are the 3 right now.
Excellent.
Got it.
All right.
Copper as a strategically copper application, once our manganese is through, and because they are copper and manganese falls in the same category as far as the industry is concerned. So I'm quite sure that copper we'll be moving after that to the semiconductor industry.
I think you're looking at like a divalent copper, right? Copper plus 2.
Yeah, so there are players in copper which they are measuring, but there we don't have any price war. And especially in semicon we don't have any price war. So strategy will be there. The next year we will exhibit in the semiconductor industry.
Oh,
Going
good.
for the copper. That's our plan. So next year, I don't know, maybe either in Korea or in Taiwan or in India, we will
Okay.
put up we are putting up a booth, and then I will send you separate email, and then your visit will be required there.
Yeah.
We will
So-
plan next year, maybe
Yeah.
one exhibition next year in semicon. If you are successful here with manganese, then state we will target for copper.
Okay.
Because in Thailand, we are going to have a good reference for copper, and people can see your units working by next year, and that's the strategy.
Okay. So-
Copper, manganese, silica.
Yeah, so just send me an email, right? You summarize those applications that you want. Try to tell me what the levels are of those anions or cations that you have in there. If you can tell me a little bit about the background, most of the times when we're looking at part per billion levels of things, the water's really clean. But when you
Yeah.
mention, raw water, there may be other things in there that I need to be aware of. And then like you said, you could pre-treat, you could do the pre-treatment, filtering it,
Yeah.
skimming it, whatever you have to do to give it to me in a way that I can make the measurement. And then some relative numbers, right? Like, I need 3 or 4 copper units, I need 5 or 6, silica units, and I want some manganese units. Just let us start to work on that part of it. And then I'll give you a bullet statement tomorrow for the reasons this is better than the next guy. And I'll also, what else was I gonna do? That's one other thing I was gonna do.
Tomorrow's Saturday, no need, I can do it by Monday.
Okay, yeah, today's Friday.
Make them work hard, come on.
7. I'm kidding. So we've got a follow-up meeting sometime midweek next week. So but if I can get those bullet points to reinforce the value proposition, I appreciate it.
Yeah,
So,
yeah.
Monday.
I'll get that to you, no problem. All right,
Perfect, all right. And thanks for your presentation.
all righty. Good. Well, now we know that this works out, we can do it again, right? And maybe we can make it a little bit better. But I think you can see everything when we brought our camera up to the unit, so.
It's a perfect idea, and I think next 1 year continuously, we will be doing it on regular basis.
Yeah, right.
Because it changes things, because the confidence level and the availability, and if something is technically not clear, we can discuss on video conferences. I think that's a perfect idea, and we will do it continue. So the start is done, and the start is done, and we will continue it.
Very
Thank
good.
you.
All right.
Thank you.
Thanks, guys.
Thanks, guys.
Thank you. Bye.
So it was good.